Hey everyone, welcome back to our Permutations and Combinations playlist. So last time we did year 2013. Today we're going to tackle the questions from year 2014. All right, so let's see the first question. All right, so let's see this. Find the number of different ways in which the 8 letters of the word Tanzania can be arranged so that all the letter A's are together. So over here we have Tanzania. Uh, we have one, two, three A's over here. So we need all the 8 letters of the word arranged in a way that A's are together. So we have T, N, Z, I, and A, A, A. 1, 2, 3, 4. Wait, sorry. What did I miss out? T, N, Z, I. Oh, another N. Another N over here. So 3 A's, 2 N's over here. So we need this unit to stay together. So that means in total we have 1, 2, 3, 4, 5, 6. 6 units. So sorry, we have 6 units. So for 6 units we will do 6 factorial. But these 3 A's internally, this group is identical. So all the A's are identical. So we do not need to do 3 factorial divided by 3 factorial because these A's are identical. However, however, these two N's can be in different places. So these are identical cases. So we will do divided by 2 factorial. So if you want to deal with this group of A, you can do 3 factorial divided by 3 factorial also. However, it's not needed, so we will just simply cancel them out. So you will have 6 factorial divided by 2 factorial. So 6 factorial divided by 2 factorial, we have 360. Okay, now the B part. Second part. The first letter is a consonant, T and Z, and the second letter is a vowel, third letter is a consonant, fourth letter is a vowel, and so on alternately. Okay, so what they're asking us to do is that since we have 8 letters, yeah, so we have consonant, vowel, consonant, vowel, consonant, vowel, 6, 7, 8. Okay, so we have consonants T and Z, and vowels are A and I. A's are repeated thrice, and N is repeated twice. Okay, so for consonants, we have one, two, three, four. So for consonants, we have 4 consonants in total because we have T, N, N, Z, I. Although like 2 are duplicates, so we will do 2 factorial. For vowels, we have also 4, but out of them are 3 identical because you have I, A, A. So these 3 are identical. Now we multiply these together to combine them both because this is a single event. This is not an OR case over here. This is an AND event over here. So happening at the same time. So 4 factorial divided by 2 factorial times by 4 factorial divided by 3 factorial. So we get 48. All right. 4 of the 8 letters of the word Tanzania are selected. How many possible selections contain exactly 1A and exactly 1A? So 4 we are selecting. So 1, 2, 3, 4. But we have one A and one N selected. So from we have T, Z, I. That's the only thing that's left, right? So from these three, we need two. So basically 3C2. So 3C2. Oh, sorry, no. 3C2. We have just three. Okay, simple, straightforward. Exactly one N. Okay, so now we have one N but multiple options for A. Since A's are identical, so we need to have different cases for them. So let's have cases. So we have 0 A's first. So N are already selected over here. So N is already selected. So we don't need the two N's over here. So how many are left if we take away A's and the N's? So we just have TZI. Okay, so just three basically. So just these three. So 0 A's, that means 1 N, 0 A's. So let's write over here 1 N, 0 A's. You have just 3C3. 1 N, 1 A, we have already done that. 3C2. 2 A's selected. So we would just need one of them. If we need three A's together, then so we will have 3C0. So total number of ways will be just the sum of all these. So you could do sum I is equal to 0 and 3, 3ci. So either way, it's fine. You can actually do that. So 3, 0, 3, sorry, 3c x. So 8. You could do this like manually also. You could do this like manually also. So 3c3 is basically 1. Oh, sorry. Wait, sorry. 3c3 is 1. 3c1 is also 3. Oh, 3. 3c1 is 3, sorry. 3c0 will be, oh, my bad, 1. 3c2 is 3. So when you add all of these together, so 1 plus 3 plus 3 plus 1, that is also equal to 8. All right, so this was an easy question. Now let's see the variant 6-2. Okay, so let's see this. Find how many different numbers can be made from sum or all of the digits of the number 1, 1, 3, 4, 5, 7, 8, 9 if all 7 digits are used, odd digits are all together, and no digits are repeated. Okay, so this is straightforward. You have 1, 2, 3, 4, 5, 6, 7. Odd digits are together, which are, so let's list down how many are odd. So you have 1, 3, 4, 5, 7, 8, 9. So out of these, you have 1, 2, 3, 4, 5. So 5 you have odd. The rest would be 1, 2, 2 even. Okay, so that means 5 are together. So 1, 2, 3, 4, 5. So we have these 5 as a unit. So we have 1, 2, 3, 3 total units, 3 factorial. And in between this 5 unit group, which is the odd number group, we will also have 5 factorial over here because these are different numbers, so they can have different arrangements. So 3 factorial times by 5 factorial, that gets us 720. All right, part B. The numbers made are even numbers between 3,000 and 5,000 and no digits are repeated. Okay, all right. So if the number starts, like if the number is between 3,000 to 5,000, so the number will be from 3,000, 1, 2, 3. We will also have it in 4,000, 1, 2, 3, but we will not have 5,000 because obviously that's the limit. However, for even numbers, the digit ending should be an even digit. So 4 or 8. So we have different possibilities also. So for 3, since we do not have any digits repeating, so 4 and 8 can come over here. So 4 and 8. But for 4, we cannot have another 4 over here. We can just have 8 over here. All right? We cannot have 8,000 because we just need it in between 3,000 and 5,000. Now, no digits are repeated. So that means the numbers that we will select for these uh, places, they can be any one of the rest. So we have taken 3, we have taken 4. So how many are left? 1, 2, 3, 4, 5. So this is an arrangement problem. See, we're making different numbers, so this is not a combination problem. This is an arrangement problem. So we will have 5p2. Same case, 5p2. Same case, 5p2. So we just need to add these together. So total would be 3 times by 5p2. So 3 times by 5 P2, we get 60. Now, the numbers made are multiples of 5, which are less than 1,000. Now, for the less than 1,000, for units, obviously, if it's a multiple of 5, we only have this. That means then digit must end with 5. So digits must end with 5. So that means there's only like one possibility, 5 over here for units. For hundreds, you have 1, 2, 5. Sorry, we also have tens also. Sorry, I forgot over here. So tens. So that would be also a number ending in 5. Okay. So all now we need is just simple translation of this. So 5 is just one number over here, like one time it can happen. Now for this thing, as you can see, digits can be repeated. So we have 7 digits over here. Any one of those 7 can come over here. So 7. Similarly, 7 can come over here, 7 can come over here. So 7, like 7, any one of the 7 digits, any one of the 7 digits, so that would be 7 times by 7. So total uh, is 1 plus 7 plus 49. So that would be 57. So 1 plus 49 plus 7, 57. And that's about it. All right, let's see the variant 6-3. All right, so let's see this. 9 cards are numbered 1, 2, 2, 3, 3, 4, 6, 6, 6. Okay. Part 1. All 9 cards are placed in a line, making a 9-digit number. Find how many different 9-digit numbers can be made in this way if even digits are together. So from this 9 numbers, we know we need to count out how many even digits are there. So 2 over here, 3, 4, 5, 6. So we have 6 even numbers. The rest would be odd. But how many are the duplicates? So we have 2 times by 2's. We have 2 3's. And you have 3's, 6's. Okay, so we need even digits together. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. All the even digits together. So E, 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 even, even, even. So basically we want an entire group of these even numbers as one unit. So how many units will we make? 1, 2, 3, 4. So total units 4 factorial. And of these 4 outside, you have 2 3's also. So duplicates, right? And inside the even, you have 2 2's, you have 3 6's also, and you have a 1. So we have to take care of these duplicate ones also. So inside the even group, we have 6 numbers, 6 factorial, divided by 4 factorial divided by 2 factorial for to take care of the 2 3's. And from this group, you have 2 2's and 3 6's. So 4 factorial times by 6 factorial divided by 2 factorial divided by 2 factorial divided by 3 factorial, we get 720. All right, if the first and the last digits are both odd. Okay, now over here we have a different case over here because we have 2 3's over here which are identical, so we could have a different case. So we could have 1 3, like 1 first, 3 last. We could have 3 1 over here, and we could have 3 3 also, which obviously they are identical to each other. So for the first two, we can do 2 times by. Now notice that in between you have how many letters, how many numbers left? 7. So you have 7 left, and of them you will have 2 2's, 3 6's. So from the 7 you have 2 2's, 3 6's, plus for the 3. For the 3, we don't have to worry about this scenario anymore, but we still have 2 2's and 3 6's. So 7 factorial divided by 2 factorial, 3 factorial. So basically it's like saying 3 times by 7 factorial, 2 factorial, 3 factorial. So 3 times by 7 factorial divided by 2 factorial divided by 3 factorial, we get 1260, right? 3 of the 9 cards are chosen and placed in a line, making a 3-digit number. Find how many different numbers can be made this way if there are no repeated digits. That means all the digits are unique. So to understand this, we need to know how many unique numbers are there. So unique numbers are 1, 2, 3. Do we have? We don't have a 4. We have 4. 1, 2, 3, 4, and 6. So that means 1, 2, 3, 4, and 5 unique numbers. So 2 has, okay, so there are no repeated digits over here. So we could have any of these 3. So 1, 2, 3. So out of these 5, we need to place 3, and obviously we need a permutation arrangement problem. So this will be 5p3, straightforward. So 5p3, that is 60. If the number is between 200 and 300, and they do not say that there can be repeated digits or not, so that means there can be repeated digits. So first we will do the same thing. We will consider the unique cases. So first we consider the unique cases, unique numbers included over here for the 2. If 2 has already been selected, then we can have any digit from over here in these 2 places. So from 5 options, we need to have arrangement of any 2. Because we do have 2 2s, we do have 2 3s, we have 3 6s. But we still want a unique number over here. However, since we have 2 3s, 3 6s, we could also have duplicate cases also. Like when you have 2 3s, whichever permutation they come in, that will be the same thing. So there is no unique identifier to this first 3 or the second 3. So both 3s are identical. So however they come, they will be considered as one arrangement, one unique arrangement. Same goes for 6. If you have 2 6 6, same thing will happen. So this means that we will just need to count these 2 further. So total would be 5p2 plus 2. So 5p2 plus 2, you get 22. And there's your question. All right, so let's see the next question. Okay, so let's see this. A committee of 6 people is to be chosen from 5 men and 8 women. In how many ways can this be done if there are more women than men on the committee? All right, so let's make a table over here. So part 1, we have men, we have women. So let's see how many cases we can actually make. So we need more women than men. So let's start out with 6. Absolutely no problem if all are women, no men. 1 less women, 1 man, 4 women, 2 men. And we don't need to go any further because 3 and 3 women, 3 men will not be considered as this case. So now let's examine these 2 cases. So 5C0 times by 8C6. We have 5C1 times by 8C5 and 5C2 times by 8C4. Okay, now I'll show you 2 ways to actually solve this in the calculator, and you can do this in your Casio calculator also. So this is based on calculator, Casio calculator over here. So Uh, the easy thing to do is to calculate each of them individually and just simply calculate it, right? So 5C0 times by 8C6, 28. Then we go 5C1, 280. And then we have 5C2, 8C4. All right, so 700. Now we just add them together. So 28 plus 280 plus 700. Now 228 plus 280 plus 700 adds up to 1008. Now let's try an alternate method in the calculator with the sum form over here. So with the sum, you can start with I is equal to 0 or x is equal to 0. Doesn't matter, whatever you want to call it. X, we just need to go up to 2. So 5C x, because x is starting from 0, we are going from 0, 1, 2. But over here, we are going from 6, 5, and 4. So multiplied by 8C 6 minus x. So each time x is improving, we are subtracting from the 6. So 6 minus 1, 5, 6 minus 2, 4. So when we plug this in the calculator, we should get the same answer over here. Now, let's see whether we can pull this off or not. 2, 0, 5, C, x times by 8, C, 6 minus x. Oh, sorry. Like this. And as you can see, we are getting this answer, 1008. You can try this in your own calculator also. You will get exactly the same answer. All right, that was just the part one. We need, okay, if the committee consists of 3 men and 3 women, but 2 particular men refuse to be on the committee together. Okay, so these are 2 men who are refusing to be in the same committee. So what we can do over here, we can classify them over here. So we can have either of those men, either of the men, either of the 2 men, sorry, just to be clear, either of the 2 men. This would be 8C3 because we have 3 women. And 1 man is already selected in both of these cases, right? So if 1 man is selected, that means we are not selecting from 5 anymore. We are selecting it from 3 because 2 people have a problem with each other. So of those 2 of them, 1 is already selected. So the 3rd place or the first place is already taken. So 3C2, because for men, let's say this guy is one of those people, one of these people who is refusing to work with the other one. So these 2 will come from the 3 which are neutral party. And times by 2, because obviously we will have 2 cases for 2 different men. We will also have neither of the 2 men also. What if neither of the 2 men are selected? So again, we have 8C3 times by, now we had the 3 people which are not part of this fight over here, so we can choose any one of them. So 8C3 times by 3C2 times by 2 plus 8C3 times by 3C3. So 392. So basically we are adding for the total over here. All right. One particular committee consists of 5 women and 1 man. So basically we had this over here. In how many different ways can the committee members be arranged in a line if the man is not at either end? Okay, so that would mean, okay, so that would mean that we have uh, 6 people. 1, 2, 3, 4, 5, 6. So man can be in these places, but not at the end. So what we would do over here for the man, man, it's 4P1, 4 places, but 1 man. But once it is selected, we have 5 places left for the women. So 5P5. So 4P1 times by 5P5. So that is 480. We could also do one more thing. We could find out all the random arrangements without any restriction. So random arrangements without restriction. So that would be just 6 factorial, right? And if we have a man at the end, at either ends, because we will have 2 cases, either end. So let's say we have man over here, 1, 2, 3, 4. Yeah. So either of the 2 cases is just times by 2. E times by. Now 1 is gone, so that means the rest of the 5 will be women. So 5 factorial, right? So we could do 6 factorial minus 2 times by 5 factorial also. So 6 factorial minus 2 times by 5 factorial, also same thing, 480. All right, now let's see the 6-2 variant of the October-November. Okay, so in the 6-2 variant, we have 2 very small questions that are that we have to do. Okay, so question number 1. The 50 members of a club include both the club president and the club treasurer. All 50 members want to go on a coach tour, but the coach only has a room for 45 people. In how many ways can 45 members be chosen if both club president and the club treasurer must be included? So this is a very, very easy question. So out of 50 members, 2 are selected, already selected, and 2 seats because of that are going to be occupied. So out of 45 seats. So the how many ways would just be simply 50 minus 2, that means 48. C 45 minus 2, 43. So 48 C, sorry, 43, we get this value 1712304. That was the first question. Now, question number 2. Find the number of ways that 6 boys and 4 girls can stand in line if all the boys stand next to each other. So that would be easy thing. If boys are together, they are forming a unit. Girls can be anywhere. So boys are forming one unit, and obviously these are uh, different units of boys. Girls can be anywhere. So 4 girls over here. So we have 1, 2, 3, 4, 5. 5 units, but inside the boys group, we will have 6 factorial also because obviously these are different items. So 5 factorial times by 6 factorial, 86,400. Part 2. No girl stands next to another girl. Okay, so this is also easy. So we have boy, 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 6 boys. Now the girls will occupy these places. So boys, we have 1, 2, 6 factorial for boys, simply as before. But for girls, we have 1, 2, 3, 4, 5, 6, 7. 7 places, but only 4 girls. So 7p4, simply. So 6 factorial times by 7p4. 604,800. And that's the 6-2 variant. Now let's do the 6-3 variant. All right, so let's see this. Part A. 7 paired dice, each with faces marked 1, 2, 3, 4, 5, 6, are thrown and placed in a line. Find the number of possible arrangements where the sum of numbers at each end of the line add up to 4. So we have 1, 2, 3, 4, 5, 6, 7, and we are counting or summing up these two numbers over here. So whatever number comes at these two ones. So to get sum equals to 4, there are not a lot of combinations over here. So we can have 1, 3, we can have 3, 1, and what else? Sorry, 2 and 2 also. I don't think there are more cases over here. Yeah, there are not a lot. So we need the possible arrangements this can happen. So now notice one thing over here. In between these over here, so in between the end ones, all of these are dice, which means that any number can come. There can be repetitions also. So this has 6, this has 6, this has 6 possibilities, has 6, this has 6 possibilities. So 6 raised to power 5, 6 raised to power 5, and 6 raised to power 5 possibilities. So 3 times by 6 raised to power 5, we get, so total would be 3 times by 6 raised to power 5 equals to 23,328. This is the A part. Now, find the number of ways in which 9 different computer games can be shared out between Vaina, Jingi, and Hebe so that each person receives an odd number of computer games. Okay, so for this, we will need to make a table of different possibilities. So So we have whatever the names are, Waina, Jingi, and Hebe. So we need odd number of distribution over here. So we can start out with 1, 1, 7. We can increase the second one, 3. 1 plus 3 is 4, so 9 minus 4, 5. See, all are odd up till now. So 1, we can increase 5, 3, and then 7, 1. Then we have, then we increase the y nows by to 3, 3, 1, 5. We increase the second one again, 3, 3, and 3. Then we have 3, 5, 1. And we can't have a 7 over here inside because obviously this would cross the 9 boundary. It will, okay. So we have 5. 5, that would be 1, 3, and 5, 3, 1. And then we have 7, 1, 1. Now, we don't want to do we don't want to find out the exact combinations for all of them. We just need to identify the pattern over here. So, to identify the patterns, you have 1, 3, 5 occurring. How many times? 1, 2, 3, 4, 5, and 6. So 6 times. So we will edit that later on. How many times we're getting 117? Like a combination like that. So we 1, 2, and 3. 3 times, and 3, 3, 3 is just 1 time. So 1 time. Okay, now we write the exact combinations. So 9C1 times by 8C3 and then 5C5. Then we have 9C1 times by 8C1. Then 7 are left, so 7C7. 9C3 times by 6C3 times by 3C3. Now, all we need is to write down the values for them. Okay, so we have 9C1 times by 8C3 times by 5C5 times by 6, because this was times by 6 over here. So we have 3024. This is also times by 3, so we will do that. 9C1 times by 8C1 times by 7C7 times by 3, we get 216. This one, 9C3 times by 6C3 times by 3C3. This is times by 1, so 1680. So total would be 3024 plus 216 plus 1680. So answer, sorry, 3024 plus 216 plus 1680, we get 4920. And that's the final uh, answer. Now, this is the end of the year of 2014. Hopefully, this was enlightening for you, enough to practice for the upcoming May-June exam, which is in the coming week. If you have any questions, do reach out in the comments, reach out on our email, WhatsApp, that's given in the link tree. If you feel that I wasn't able to explain a certain question over here enough, same thing, reach out to us through the comments. That's the only way I can know. If you think I've made a mistake somewhere, please reach out so I can correct it. Otherwise, best of luck. See you in the next video. Bye bye.